All right, here's one that's not necessarily a complex fraction, but a situation where we can simplify this a little more, and we need to because, or at least it would be beneficial to, because as it stands, if we're approaching 3, we can't directly evaluate, because if we plug in 3, 3 minus 3 is 0, so we end up with a 0 in the denominator. So what we do here is we want to try to combine these fractions, make them into one fraction, just simplify this algebraically, and try to make it to where it is where we can use our limit laws or directly evaluate. Okay, and so what I would do is factor this denominator first. It's a simple quadratic, so we have x here, and remember, simple just is because we have a 1 in front of the x squared, and so then we can find numbers we can multiply to get 3, or numbers that are factors of 3 that subtract to get 2, right? So that's 3 and 1. This tells us the sign of the bigger number, so the 3 is negative. And since this is negative, then that means the other sign is going to be different, right? Signs are going to be different. Now, the reason we do that is because now we can see that this can be the least common denominator, right? We have part of it here in the x minus 3, so all we need to do is tag on this x plus 1 to this, and we'll be good to go, right, with common denominators. So that's what I'm going to do, is I'm going to multiply by x plus 1 on the bottom here to get that common denominator the same, but whatever I do to the bottom, I have to do the same thing to the top, right? So I'm also going to multiply the top by x plus 1. So then what we'll get is we'll get the limit as x approaches 3 of x plus 1 on top over x plus 1 times x minus 3, right? And then this other fraction we can keep the same on top, and then the bottom we just put it in its factored form. Okay. All right, and now we can just combine the numerators, right? So I can just do x plus 1 minus 4, and then this denominator is going to stay the same, right? So it's going to end up being the limit as x approaches 3 of, and then on top, 1 minus 4 is negative 3. So we get x minus 3 on top, and then on the bottom we have the x minus 3, x plus 1, right? And so now we can see that these are going to cancel out, right? And that seems to be the common theme here, right? Is these things seem to cancel out. So we kind of expect that now. So on top, all we have left is an invisible 1 that we're going to include now, because when there's nothing else there, you have to put the 1, right? And then x plus 1 on the bottom, right? And the nice thing about this is now I can just plug in 3 and directly evaluate here. So 3 plus 1 is 4, so it becomes 1 over 4. All right, let's take a look at this one here. This one's an interesting one, because here we could use our limit laws, right? Like if I plug in, and it seems that we could directly evaluate it too. If we just plug in 3, we can see that 3 minus 3 is 0, and the square root of 0 is 0, right? So this is defined at 3. The problem is that it's not, it doesn't exist to the left of 3. So if I were to plug in 2 here, right, or even 2.9, I would end up with a negative underneath the square root, right? And if we have a negative underneath the square root, that's an imaginary number, right? One that we can't graph. And so so it's not the function doesn't exist at those points. And so, at least not on the real coordinate system, right? And so so this right here, the limit as x approaches 3 from the left, does not exist. Okay, so it'd be DNE, or the backwards U with the line through it there. Okay, but if we're coming from the right, it does exist, right? Like, so if we're coming from the right side, we can make it all the way to 3, and we know it approaches 3, so we can actually directly evaluate this and just plug in 3. 3 minus 3 is 0. Square root of 0 is 0, so that would just be 0. Okay, so you have to sometimes think about, okay, what are you dealing with here? This isn't something we can multiply a conjugate by, because we don't have a numerator and denominator. So we were able to do that because we we could multiply the top and the bottom by the same thing, right? Here, that's not the case. And so there's really nothing we can do to cancel this out or to modify it. And we know that if we have a negative underneath the square root, that'll be imaginary. And so so sometimes we have to kind of use some of our facts that we know, our understanding of limitations of certain types of functions, and apply those in certain situations. Okay, so this one doesn't exist, but this one does, right? And just to show you graphically, here's the actual function, right? Square root of x minus 3. So you can see that the function actually comes to an end here at x equals 3, right? So on the left side, if we come from this side, there's nothing there, right? It's non-existent. So that's why the function doesn't exist from the left. But from the right side, we can see that as we get closer and closer to 3 on the x-axis, we get closer to 0 on the y-axis.